Good afternoon and good morning to those of you out west. Welcome to today's demo cast from the Construction Specifier in Georgia-Pacific. My name is Tristan. I am the Associate Editor for the Construction Specifier, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started today, if you have any sort of questions during today's demo cast, please enter them using the Q&A section, which you can find there at the bottom of your Zoom window. We will address as many questions as possible at the end of the presentation. While Zoom does have a raise hand function, we're going to be keeping everyone's mics muted, so please just use the Q&A instead. If you're experiencing any technical difficulties during the demo cast, you can also enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's demo cast is being recorded and will be available on the Construction Specifier's website by this time next week. Now, I'd like to introduce our speaker, John Chamberlain. John is a Director of Product Management for Georgia-Pacific Building Products. He has worked in the construction products industry his entire career, with most of his work focusing on new product development for disruptive technologies in building envelope space. John is actively involved in the industry, serving as a director for the board of the Air Association of America, a member of multiple committees, and his local building enclosure council. He is a frequent speaker on the subjects of new innovations in construction materials, quality and continuity of the building envelope, and new construction processes such as the off-site construction. In today's demo cast, John will present an in-depth look at how dense element barrier system and Densify liquid barrier can deliver a more efficient water-resistant barrier and air barrier. You'll learn everything you need to know about the systems and gain insights on how the products work together to provide continuity across multiple substrates. John, we appreciate you for joining us today. Please take it away.
Thank you, Tristan, and thank you everyone out there for joining me today. So let me begin by talking about dense element barrier system. I hope that many of you are familiar with this already, but if not, great time for me to make that introduction. So dense element barrier system is an integral water resistive barrier and air barrier sheathing system. And loosely, or I guess simply what that means is the sheathing itself also acts as a water resistive barrier material and air barrier material. This isn't a new concept. Products like this have come onto the market for the last several years and are growing. In fact, Georgia-Pacific also has a product more residentially focused called Georgia-Pacific Force Field Weather Barrier System. But what is somewhat unique about dense element barrier system is that it is for commercial construction, and specifically, it is a gypsum-based, glass mat-faced exterior sheathing. So we think about why we are using gypsum-based glass mat-faced exterior sheathing similar to Den's Glass Gold. And we know that first and foremost, it's for fire safety, for the ability for us to construct hourly fire-rated walls. And so we have taken this same concept of what do we need from an exterior gypsum sheathing and what do we look for in terms of performance and in terms of the ability to maintain our building envelope controls, to hold out water, to better control the movement of air, not allowing it to pass through on its own. And we have brought this innovation to the market. So in 2015, Den's Element Barrier System was launched, and it provides all of those attributes that I just mentioned. You get an exterior gypsum sheathing for construction of hourly fire-rated walls, and you also get the inherent water-resistive barrier and air barrier benefits that you would normally get in a secondary process. So typically, you install your sheathing, or in a more traditional fashion, you install your sheathing, and you go back around the building with perhaps a building wrap or a fluid-applied barrier or maybe a self-adhered barrier. And now we're taking a lot of those steps out. So we talk about why. Why is this becoming a much more popular option? Why is this growing in terms of systems that you see from various manufacturers? Why is the market adopting this so quickly? And it really becomes something of an efficiency multiplier. When we take trips around the building out, we're allowing for construction to stay on schedule. We're allowing for even perhaps compression of the schedule and maybe reduction of labor or an ability to address the lack of labor. And we're also simplifying quality control. We're potentially reducing the amount of rework that needs to be done. And we're not making any negative trade-offs in terms of performance. We're still getting that same level of performance in terms of fire resistance, water resistance, air resistance. And what's really truly unique about Den's element barrier system is, whereas those other products that I've alluded to are typically a standard type of sheathing with some other water resistive barrier added on top, this one really is innovation in the sense that the water resistive nature of it is integral into the sheathing itself. So it's actually baked into the product. So with that introduction, let's talk through some other inherent benefits of Den's element barrier system. So here comes the demo part of the demo cast. You can see, just like a Den's Glass Gold sheathing as an example, this product scores and snaps and installs just like any glass mat gypsum sheathing that you would be using in a commercial construction project today. Now, I mentioned already, the board itself is your water resistive barrier and your air barrier. So you create the continuity of your building envelope, of your water barrier and your air barrier, via this DensDefy liquid flashing. And we've really tried to prioritize ease of application. So you see it spreads very similarly to peanut butter, and really tried to focus on how do we make all of this continued benefits of schedule compression and reduction in quality control kind of inherent in the whole system. So you see that DensDefy liquid flashing goes on as a liquid product. It can be spread very easily, and it conforms really nicely to some of these complex geometries. It is an STP-based product, which means it can be installed in lower temperatures. It can be installed on damp surfaces. It cures and skins very, very quickly. And it becomes the second component and allows for completion of your water resistive barrier and air barrier system with Den's element barrier system. Now, as I mentioned, that has become a very popular trend in ways to construct. And obviously, you're seeing more and more projects using Den's element throughout the country. In fact, we've got over 800 projects that have been completed, very close to 900 in construction right now. And this is ranging across all sorts of vertical segments. Commercial construction obviously can be healthcare or hospitality or education or government. And so we're seeing all of those really taking to the benefits of the Den's element barrier system. However, there's a bit of a trick, a problem with integral WRB AB systems, not just Den's element, but in fact, all of them. And that is that very rarely is your sheathing the only exterior wall substrate. So here you've got some examples, some images where Den's element barrier system is being used on these commercial projects. And in almost every case, you're finding concrete or CMU or some other wall that still needs a water resistive barrier or an air barrier or a combination of the two. Now, the challenge with these systems is, how do you maintain that continuity? How do you know that you're going to have the same level of performance in these areas where your integral WRB sheathing stops? Or if you even have a strategy figured out for that, how do you feel confident in those connections? How do you tie them together? So continuity, first of all, it's critical. It has to exist. Otherwise, you're not going to have proper water resistance, proper air controls. So the obvious answer is, let's go to another product. And you can see in that middle picture, as a really good example, there's some blue stuff around the Den's element barrier system that is providing the water resistive barrier and air barrier on this cementitious or CMU substrate. Question two becomes, how do we know how this other system is going to interact with the integral WRB and air barrier system? So we can assume reasonably that the secondary system can be installed, and we can assume that there are ways for that to connect. But now you have potentially two different manufacturers, maybe two different trades that are trying to understand proper sequencing, proper application method, and probably most importantly, compatibility. How do we know that these systems can marry together in a way that's going to continue to allow the building to perform as it should through the duration, through the lifetime of the building? And another very obvious question that comes right on top of that is, let's say something does go wrong. Who's responsible at that failure? Who's responsible when the products don't connect well together? And I'm here to tell you, there's a lot of different ways to construct. So of course, there are multiple ways to make this happen. But when you're talking about manufacturers who have their own formulations, who aren't going to immediately share proprietary information, or maybe just don't know enough about the other systems out there, it's very difficult to get any one manufacturer to sign off on the use of another manufacturer's materials. And so we have this problem, this issue, right? And we want to maintain continuity. That's really the key to good performance. And then we have this challenge of maintaining continuity across different systems, potentially with different manufacturers. And what you see today is that in some cases, people they go for it. They use a system that they're familiar with. Perhaps the scope of work for cementitious substrates belongs to a waterproofer, and so they're going to use a system they're confident with. Maybe it's the drywall installer who has responsibility for installation of dense element barrier system. And so they kind of work in their own silos instead of coordinating with each other. And maybe that can work, but there's a lot of uncertainty. There's a responsibility for a decision that falls to someone in that project team. And the bad day is when things don't work out, when there is not good compatibility. And sometimes we have obvious signs of that. Maybe we see bubbles or fish mouths, signs that there's not good adhesion. Maybe we see poor adhesion that actually will pull away prior to something else getting covered up. So if we're lucky, we can catch this early. But a really bad day is over time, as the building continues to move, there's a degradation driven by a lack of compatibility. And so that's what you want to avoid. That's what Georgia-Pacific has recognized as something that our customers need and want and are asking for our guidance on. And so I'm happy to announce that earlier this year, we launched a new system, the DensDefy liquid barrier system. We took a look at what is so popular about Den's element barrier system, being the efficiency of installation, the ability to condense construction schedules, just the sheer ease of quality control. And we said, how can we carry that forward on substrates where you're not going to have a gypsum sheathing? So DensDefy liquid barrier has all of those same attributes that you see in our liquid flashing. It's very easy to install. It can be installed in lower temperatures. It can be installed on damp substrates. It cures and skins very quickly. And most importantly, we know very well how it's going to interact with components of the Den's element barrier system, with the other DensDefy products. And so Georgia-Pacific is now able to offer a limited warranty for systems branching across not only Den's element, but also substrates that are protected with DensDefy liquid barrier. And so again, here's the demo part of our demo cast. So in this example, you see that Den's element is running up into something load bearing, in this case CMU, and you see the same DensDefy liquid flashing that's used to complete a Den's element barrier system can now be used for these joints and these gaps between substrates. The product itself has high elongation, so it bridges very well. And once that has cured up, you've got good continuity of an air barrier from the Den's element over to the CMU. You'll see that now, once you've done your visual inspection and made sure that you don't have any voids and pinholes, you can move on to address any areas of discontinuity for the Den's element barrier system itself. So again, spreading over our joints and seams, making sure that any fastener holes are covered up. So those are opportunities for water or air to get in, and we do require that those get covered. And just coming back and tying it all together so that your air barrier and your water resistive barrier are good and continuous. These products, simple to install, easy quality control, making sure that you have a proper mill thickness. For the liquid flashing, it's approximately 16 mils, so not a lot of material. For the DensDefy liquid barrier, which you now see being installed, we recommend a minimum of 14 to 18 wet mils, but you're gonna find on porous substrates such as CMU that you really go for a void and pinhole free surface. You may not be able to hit exactly 14 to 18 mils, but because this product installs very simply, much like rolling paint, it's very easy to get that monolithic surface with only a couple of passes. And so There we have Densify liquid barrier. I realize that was fast, and there will be time for some questions. But really, here's the value proposition in a nutshell. So we are going to continue construction. There is going to continue to be an expectation for high performance throughout the lifetime of the building. And at the same time, we're going to be challenged by compression of our construction schedules, by a lack of available labor. And again, there's always a look to opportunities for value engineering. And so Georgia-Pacific has heard these challenges, and we're rising up to them, and we're doing that through innovation of products and services. So today we have our DensElement barrier system. We're now able to extend our protection against water intrusion, against unwanted air movement with our Densify liquid barrier system across all exterior walls. And you don't just get the products with that. So we are able to provide a warranty that works against water and air across all of these walls, as I mentioned, as well as providing those technical services that our customers need. So guidance around proper installation and application, even at the design phase where you need spec guidance, details, tips and tricks for proper connections at any areas where you're going to have dissimilar surfaces or penetrations. And we're going to carry that through all the way to actual in-field observations. Training is available. Again, best practices and tips and tricks for how to install the most efficiently. And then the nature of the products and the systems themselves are going to give quite a lot back because of the nature, because they're simple, and because the quality control is very simple as well. And we do have a hotline. You'll see the number here. That'll be available as well on all of our marketing material and websites, so that you can very easily and quickly access the technical services department. In fact, if you want to get a hold of Tyson Lodge, our actor for the demo part of this presentation, he's right on the other end of that phone line. So with that, I did want to make sure that I left time for questions, because I know there will be a few, and say it's probably a good time to fire away.
Okay, thank you, John, for your excellent presentation. And as he mentioned, we have some time for questions now. So just open the Q&A located at the bottom of your Zoom window and post your questions there. And we actually already have a few coming in, so let's get started with these. The first question we have: for dense glass sheeting that's been installed and exposed to the weather for over 2.5 years, is there any way to treat the existing sheathing to keep it, as opposed to removing and replacing it?
Yeah, so this is not really a question about anything that I just talked about, but I can address it pretty quickly anyway. DensGlass sheathing as well as DensElement sheathing both carry an industry-leading 12-month exposure warranty, but realistically, after 2.5 years, there's going to be question about how well that material has held up, just as there would be for any material that's been exposed for that period of time. So my recommendation would be to contact our technical services, but it's most likely that we would want to replace that.
Thank you. And another question here asks, is there any structure value to the DensElement? Can things be attached to it, or must various anchors be attached to it through studs or similar items?
Yeah, excellent question. Just like other gypsum sheathings, DensElement sheathing is not structural. So fasteners for claddings and such do need to go to the structural elements behind the sheathing. Georgia-Pacific does manufacture a structural integral WRB air barrier sheathing called Georgia-Pacific Force Field. And that's a wood-based product, so very common in residential and multifamily construction.
Thank you. And another question here asks, do you recommend ABAA quality assurance in addition to visual inspection of air barriers by the applicator?
Yeah, great question. Kind of crossing different worlds for me here, because I am very active with the ABAA. So my opinion is yes, there's a lot of value with the ABAA quality assurance program. And if the building owner truly wants to have confidence in how their building is constructed, and the long duration of their air barrier, then I think it's a good investment and really a minimal part of the overall project cost. All of that being said, it's certainly not required. And I think that the simplicity of our system has really allowed us to achieve some pretty monumental results in terms of air tightness, because really what you see is what you get. So speaking from experience, we've had projects that have met and exceeded Passive House standards on the first go round without a lot of rework. And again, it's because you're installing your sheathing, you're addressing any areas where there's discontinuity, and it's so in your face that it's very, very quick and easy to achieve air tightness. But overall, yes, I think the ABAA QAP program is a good service if your owner is willing to pay for it.
Another question here asks, what are the perm ratings for these products?
So both DENS Element Barrier System and DENS Defy Liquid Barrier System are vapor permeable systems. They allow for drying in the case that there's any kind of incidental moisture that might get behind the cladding or into the assembly. And both of those systems have a perm rating greater than 20.
A question here asks, what is the modulus of elasticity for expansion joints in seismic areas?
You know, that's really going to depend on the project and the engineer. So that's not really specific to our systems. I can tell you that the DENS Defy liquid flashing does have a high elongation, greater than 200%. However, it's not intended to be used as an expansion joint for seismic conditions.
And a slightly less complicated question asks, what is the drying time for after application?
Excellent question. So I mentioned that both the DENS Defy liquid flashing and the DENS Defy liquid barrier are STP-based products. So STP is one of these hybrid chemistries that has kind of all the good things that you're looking for in silicones as well as in urethanes. And what that means for your question is they skin over, they're dry to the touch very, very quickly. So in what I might think of as normal conditions, where you have somewhere between 50 to 70% humidity and maybe it's 50 to 70 degrees outside Fahrenheit, you're probably going to have dry to the touch in less than an hour, maybe as little as half an hour. Humidity, temperature, those do have an impact on how quickly it cures. If it's more humid and warmer, it cures much faster. If it's colder, it's going to take a little bit longer, and it will take, temperatures do need to be, I think it's 32 and rising for it to cure fully. But in terms of dry to the touch and ability to move on and keep doing work, it's very, very quick.
Another question asks, how do subsequent fasteners penetrating the water or air barrier get sealed?
Great question. So I think the industry at large is very familiar with ASTM D1970, which is the nail sealability or fastener sealability test. The first answer is DENS Element Barrier System has also passed that test. So we have a testing matrix which catalogs all of the various and rigorous testing that the system has gone through. And you'll note that that ASTM D1970 nail sealability test is included on there. We passed, and we passed very successfully. So right out of the gate, that's a very easy answer. You don't have to do any additional steps to seal any kind of cladding fasteners. When we talk about the fastening of the board itself to the building, we do require that all of those fasteners are protected with the DENS Defy liquid flashing. So that protects against any incidental moisture intrusion or air leakage. But when we're talking about cladding attachment or perhaps insulation attachment, it's not required. Sometimes there are steps taken, such as wet setting the fastener. And we actually have quite a few studies that we've done on that as well, and white papers on our websites specifically related to how these cladding fasteners interact with our system. And you'll see that we've done quite a bit of testing and shown really great results in terms of water holdout and air holdout without any additional subsequent steps.
Another question asks, has the dense element sheathing system been accepted by aluminum or metal composite material panel systems as a required water barrier or air barrier behind it?
Required, no, but maybe that's not the question you're asking. So yes, we have several projects that have used metal claddings and metal panels as the exterior cladding with dense element as the water resistant barrier and air barrier behind it. Without pointing out any specific manufacturers, there are a couple that have included us in their technical hotlines or technical bulletins as acceptable water resistant barriers. And we've also got some NFPA 285 decisions that favor us behind metal panels as well, even with continuous insulation. So the short answer is probably yes, it's done quite often.
And another question here asks, what is the bridge or crack bridging capacity?
So the crack bridging capacity of the Densify liquid flashing, I think, is what you are asking about. And we do offer guidance in our installation bulletins, but it's maybe not as much a question about the ability of the product as it is economics. So on the one hand, Densify liquid flashing can bridge joints, I want to say up to half an inch, let's say very easily. However, once you're getting that much, you're really putting a lot of material in there, and it might not make economic sense. So we do have another product, Densify transition membrane, and it's really good for those larger gaps, those larger areas where you just don't want to pour a bunch of liquid flashing in there. Even if you're using a backer rod behind it, you're going to end up using probably more than you would prefer. And so that Densify transition membrane is a really good solution for those bigger joints. Also AMA certified, also high elongation, and also tested for full compatibility across the Densify suite of products.
A question here asks, is the dense element compatible with other envelope material, or is a transition required?
Maybe struggling for an exact answer here. So, you know, where I see this come into question a lot is at parapets. So how is the water protection, weather protection of your roof system going to tie in with the Dens element and Densify systems? And the answer is yes, there's transition that's required. We would recommend the Densify line of products in that case. But you'll actually see, if you take a look at our details, that we've addressed this 2 or 3 different ways, because it does become more a question of sequencing. And then what we're going to recommend in that situation is a field adhesion test to make sure that the products are able to adhere to one another well.
And another question somewhat related to this one asks, how does the system work with rigid continuous insulations like polyiso?
A system works and is used quite often behind rigid insulation, including polyiso, XPS, and EPS. So one of the really nice benefits of the Dens element barrier system, and where I highlighted that the water resistance is actually baked into the board, is that our integral WRB AB sheathing still maintains that non-combustible classification, the same thing that you would get with DensGlass Gold. So it's non-combustible. It has a 0 flame spread, 0 smoke development rating. And that doesn't mean that it's an automatic check mark when we're talking about NFPA 285, but that's probably where this question is going. Can you use it behind rigid insulation, and how does it impact fire testing? And so you will find that we have a number of approvals related to NFPA 285 it's probably a path of least resistance, because most other traditional water resistive barrier technologies do have some degree of combustibility. And so while you can achieve NFPA 285 approval with almost any of them, there's probably some additional steps, some additional considerations that need to be made. Dense element barrier system is very, very simple. My one caveat, because rigid insulations tend to be vapor impermeable, would be it's best practice to include a drainage cavity between the dense element barrier system and the rigid insulation. And actually, I'm going to go ahead and tell you guys, it's best to include a drainage cavity regardless of what your WRB is, between your WRB and your rigid insulation. You want the water to have an opportunity to drain away and dry out, as opposed to being held immediately up against the WRB by a vapor barrier material. So that's probably more than what you wanted, but hopefully I got to the crux of the question.
Well, thanks, John, and thanks to everyone who joined us today. That's all the time we have for questions. If you need to reach out with any additional questions, the presenter's contact information is currently up on the screen. Just a reminder before everyone leaves, if you'd like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the DemoCast within a week. So keep an eye out on your inbox. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey, as it helps us to continue to serve your needs in the future. On behalf of the Construction Specifier and Georgia-Pacific, thank you again for joining us, and enjoy the rest of your day.
Thank you.